This video corresponds with Chapter 9, Day 2 notes. Chapter 9, Day 2 notes. So far we've been talking about hypothesis tests, and we've been talking about formulating a null hypothesis and an alternative hypothesis. And today we're going to talk about the conditions or assumptions that we have to check before we proceed with our next type of inference procedure, which is the hypothesis test. So if you look at Day 2 notes, Chapter 9, Day 2 notes, Chapter 9, and you look at where it says do now. This is actually a review question from the sampling distribution unit. So this is review from Chapter 7. It says, suppose that 84% of students at a large school regularly use a backpack. So first question I'm going to say is, what is that 84%? Is that a population parameter or is it a sample statistic? I'm hoping you're saying it's a parameter. So if it's a parameter, we use the letter P without the hat because that's the population proportion. So that means the true proportion of everyone in the school who uses a backpack is 84% P. Imagine taking a simple random sample of 100, that's N, that's the sample size, and calculating the P hat for that, the proportion of people out of this sample who carry a backpack. Describe the sampling distribution of P hat. So we've been doing this all along, we've been describing, and remember when we describe, we have to remember our socks. So describe really means shape, outliers, center, and spread. We're specifically going to just hit shape, center, and spread here. So I want you to take some time here to think about what is going to be the shape, the center, and the spread. And I'll give you a hint. You're going to look at your fact sheet for proportions. So for proportions, remember this is a proportion question. What is going to be the shape, center, and spread? Take a minute here and write it down. So I just want to remind you guys for proportions, if you were looking at your fact sheet, that the shape is approximately normal if the rule of thumb is met that n times p and n times q are greater than or equal to 10. So we're going to check that out now. Is it approximately normal? And if so, why? Okay, so we're going to do n times p. Is it greater than or equal to 10? And n times q, greater than or equal to 10. So take your sample size 100 and multiply by the advertised proportion p, and you're going to get 84. That's bigger than 10. And nq is going to be 100 times 0.16, which is 16, and that also is bigger than 10. So because these are both met, the sample size is large enough that the sampling distribution will be approximately normal in shape. Now we're going to go on to center and spread. A center is going to be the mean of all the p hats. So remember, you take a sample of 100, find p hat of the number of people who are wearing a backpack, find the p hat, plot it. Take another sample, plot it. Find all the p hats and plot all the p hats, and that's called the sampling distribution of the sample proportion p hat. So it's not all the individuals in the population, it's all the p hats, all the values of p hat. So where should all the p hats be centered at? I'm hoping you're remembering that mu sub p hat should equal p. Mu sub p hat should equal p. That is from the formula sheet. So p is 0.84, so it should be centered at the true parameter 0.84. Okay. The spread. Spread is sigma p hat, and we have a formula for this. It is on the reference sheet. The formula is p times 1 minus p over n. Remember, if you have p, you use p. And if you don't have p, you use p hat. Okay? So let's calculate this and see what we get. So we get 0.037. All right. So remember, standard deviation is the average deviation from the mean. So we would say on average, the value of p hat differs from the mean of all the p hats by 0.037 or 3.7%. All right, so now we have our shape, center, and spread described. Now, the reason why that was important is because today we're going to talk about setting up a significance test for P, for proportions. And one of the things that we need to check when we are doing the phantoms, which is the significance test procedure, is we need to check the assumptions or conditions. And those are the rules of thumb that we addressed when we did our sampling distribution chapter, which is the one that we just discussed. Now we talked about NP is greater than or equal to 10 and NQ is greater than or equal to 10. So there is one rule of thumb that we didn't get to talk about just now, which we should have, and that was the rule of thumb for spread. So remember, for spread, you were supposed to check that 10 times n is less than the population of interest. And if that is met, then you're allowed to use that standard deviation formula. So 10 times 100, you're supposed to check that that equals 1,000. You're supposed to actually write it out. And is that less than the population of all the students at the school? And it should be met because it said it was a large high school. So remember, you're supposed to check that before you proceed. That is going to be one of the assumptions that we check today. So going back to your notes, scroll down a little bit, you're going to see performing a significance test about P. Here's another example. According to the U.S. Census Bureau, the proportion, so I'd circle the word proportion and remind yourself that that's PZ, proportions, we're going to use Z, of students at the high school who have a part-time job is 0.25. All right, so again, that's all students at the high school, so it sounds like that 0.25 is the parameter, or the true proportion of all the students at the high school who have a part-time job. An administrator at a local high school suspects that the proportion at her school is less than that, okay? So she's suspecting or hypothesizing that at her school, it's less than 0.25. So if we were to set up the hypotheses, remember the HO is called the null hypothesis, and that's the one that always has the equal to sign. That's the one that it's like a statement of no change based on the past. So the parameter of interest, P, is the true proportion, oh, it says it right here, of all students at the school who have a part-time job. So the null is that the true proportion at her school is the same as the U.S. Census Bureau, what they advertise statistic, which was 25%. But then the alternative hypothesis, the HA, that is what she's trying to prove. So the administrator suspects that the proportion is less at her school. So remember, that's called H sub A. And that is really what you're trying to prove. So she's trying to prove that indeed the true proportion is less than 25%. Notice we use the symbol P, which is the parameter. We don't use P hat in the hypotheses, only parameters in the hypotheses. Notice you also use the equal sign in the null, and the alternative is always just either a greater than, a less than, or not equal to. This is called a one-sided tail because it's just a less than sign. In words, this means the true proportion of students at her school who have a part-time job is less than the national average. Is less than the 25% national average or national proportion being advertised. So she's trying to prove this, HA, okay? So now it says the administrator selects a sample, a random sample, remember that's important, of 200 students, that's N, and finds that 39 out of them, so we're going to do a proportion, and that's going to be called P hat, by the way, because we have an of, we know that it is a dividing situation, and it is a statistic because it came from the sample, and we're going to get our sample proportion, 39 out of 200. We get 0.195. Okay, so her sample from her school, she got 0.195, or about 20% of her sample had a part-time job. So she sees that that number is less than 0.25. So she's wondering, is this statistically significant enough for her to reject the null hypothesis and rule in favor of the alternative hypothesis? That's her goal. All right. So before we proceed with our inference procedure, we have to check our assumptions or conditions. And you guys remember when we were doing panic for intervals, right? The A step was the assumption step, or conditions or rules of thumb. Now, when we do what we're about to do, which is going to be a significance test, we are going to use a different word to remember the steps. Just like panic, we are going to use phantoms. And just like panic, we have to remember what these letters mean. So I'm going to write phantoms here. And this is going to be for a significance test. Okay, and when we get up to that A, the A is going to be the same thing. Assumptions, conditions, rules of thumb. So I'm addressing this before we fill in the blanks and do the entire procedure when we're back together. All right. So going down to it where it says check if the conditions or the assumptions are met. So I want you to think about what were the conditions that we did for panic, which was a 1 prop Z interval. When we did a 1 proportion Z interval for proportions, what were the things we checked? We checked if it was a SRS, a simple random sample taken from the population of interest. We checked if 10 times N was less than the population of interest. And lastly, we checked if NP and NQ were greater than or equal to 10. We're going to check the exact same thing here for the 1 sample, 1 proportion Z test. Sorry, this is going to be called a 1 proportion Z test. Instead of a 1 proportion Z interval, it's going to be called a 1 proportion Z test. So let's check these assumptions. Assumption number 1, is it an SRS? It stated that she took a random sample from her school. So we're going to assume that random sample is a simple random sample because that's a valid assumption. Next one, number 2, we're going to check that 10 times N is less than the population of interest. So her sample was size 200. 10 times 200 is 2,000. Is that less than the population of all students at her school? Only if her school is big enough, right? So we will hope it is, if it's a large high school. That's met. And then the last one we have to check is N times P and N times Q are greater than or equal to 10. So now here's where you may have a little question about, do I use P or P hat here? So if you have P, you use P. And if you don't have P, you use P hat. We technically have the P that we're assuming to be true in the null. What we are assuming in the null is that the true proportion of people who are having a part-time job out of all the high schools is 25%. So we're going to use P here because we have P. If we didn't have P, we would use P hat for the confidence interval. So we're going to use P equals 0.25. And I'm going to call this P sub 0 because it is the proportion that we quoted in the null. So the true proportion was 0.25. So we're going to do 200 times 0.25, and we're going to do 200 times 0.75, and we're going to write what we get and see if that equals a number that is greater than 10, which it will be. So 200 times 0.25 is going to be 50, and 200 times 0.75 is going to be the complement of that, 150. So those are bigger than 10. So thus, the sampling distribution of P hat is approximately normal. So all of this is not new. It's not new. It is review from both chapter 7 and what we just did, the 1 proportion Z interval for proportions, right? So now you may be thinking, well, where are we headed? So I will tell you where we are headed. If you look at the word phantoms, okay? Phantoms. We're going to talk about what these stand for. All right, and this is how we are going to follow our procedure. So P, the P step is exactly the same as the past. Population of interest, stated, and parameter of interest. We did that last topic, which was our one prop Z interval. We did the same thing. Now the H, that's a new one. So let me star the new ones. We know P. H is the hypotheses. So H stands for hypotheses. And basically you're going to state your hypotheses, your null and your alternative hypothesis in words and symbols. Okay, so we actually already did this for the question here, but it was kind of given to us. They have the HO and the HA in both. Well, they had the symbols actually, and then I wrote the words in for you of like what that really means in the true life scenario. So that's the hypotheses. Now, very important when you do your hypothesis that you're only using parameters in the hypotheses. So if it's a P question and P hat, you're going to use P. And if it's a mean question, you're going to use mu. So just remind yourself of that. Okay, the A step is the same. That's assumptions. We just went over those. There's 3 that we have to check for this process. The N step is the same. The N step is the name the procedure. So we have a new name today. It's close to the 1 proportion Z interval. It's called a 1 proportion Z test. All right, we're done with that. Okay, now T, this is new. So I'm going to star this. The T is going to be the test statistic. Okay, so the test statistic means you're going to find either the Z-score or the T-score, depending on if it's a Z or a T. Since we are doing proportions, it's going to be a Z-score. So this actually means find the Z-score for whatever it is that we're doing. And then after we find the Z-score, we're going to do something else new, kind of review. We're going to obtain the p-value. The p-value is going to be the area under the curve corresponding to the z-score. So let's go back to our question. Here we go. We know that our sampling distribution was approximately normal because of our last rule of thumb being met. Okay, because it's approximately normal, now we would have been able to draw a bell curve. And remember, it should be centered at mu sub p hat equals p, which was 0.25. Now, the administrator took a sample of 200, and her sample statistic that she got was 39 over 200, which was 0.195. So remember, we have to plot the 0.195, and in this case, that is to the left of the mean. P hat equals 0.195. So what we would do now is shade the area in the direction of your HA. So in HA, we presumed that there is a less than sign, which means it's to the left. So we want to shade to the left of our P hat, which is our sample proportion. Now we're ready to do our Z-score. So our Z-score, remember, it used to be X minus mu over sigma, but now this is P hat. So it's P hat minus mu P hat over sigma P hat. And you guys know we did this last chapter. You're basically just taking X out and you're replacing it with P hat. So we would do 0.195, which is like your X, minus the mean, which is 0.25, and then divided by the standard deviation. Now remember, the standard deviation of P hat we got from P times 1 minus P over N. So if you have P, you use P. If you don't have P, you use P hat. It doesn't look like we got it for this one, so we're going to do that one now. We're going to do the square root of P, which we're assuming in the null is 0.25. 1 minus P. I'm putting a little sub-zero here, in case you're wondering what this is. This is like a sub-zero. So 0.25, 1 minus 0.25, which is 0.75, over N, which was 200. So now what we're going to do is we're going to get our Z-score. That is our test statistic. All right, so when we say T for phantoms, that's the test statistic. We're going to get the value of Z. And then what are we going to do? We're going to find the area to the left of that Z-score, aka to the left of this P hat. All right, so let's get our Z-score, and then we'll remind ourselves how to do that. So you're going to plug in the calculator, your Z-score. It's going to be 0.195 minus 0.25 over square root of 0.25, 0.75 over 200. All right, we're going to get our z-score. We got negative 1.80. Negative 1.80 for our z-score. That's our test statistic. And now what we would do is we would either go to table A or to our normal CDF, and we would get the area to the left. So table A, you would look at negative 1.80. Normal CDF, I'll show you how to do it. Second vars. Number 2, normal CDF. This should be a review for you guys. Lower bound is negative infinity. Upper bound would be your 0.195, which was your p hat. The mean was the 0.25. And then the standard deviation was whatever we just got for the standard deviation. Did we do it? Let's see. Sorry, I don't know if we did it. Let's do it now. 0.25 times 0.75 over 200. We got 0.0306. So I'm just going to write that down. Okay. All right, so let's do it again. Stat, calc. Nope, second vars. Just kidding. Normal CDF. Lower bound. Upper bound. Mean. Standard deviation. 0.0306. And then when we hit paste, we're going to get our area under the curve. And I got 0.036. Oh, interesting. 0.036. So this is called our p-value. I'm going to check that that's right because I feel like, why would that be the same? I don't know. I'm going to check it using our table A. So let's do that now. So if you do look at the table at negative 1.80, it is 0.036. So it's the same, 0.0359, same. All right, nice. All right, so that's our p-value. So we're almost done with phantoms. So now if you look back at phantoms, we got the test statistic, that's our z-score. We obtained our p-value, and now we get to the m and the s, and this is what we were talking about to lay the foundation of this. This is also new. The m is make a decision. So you're not just making a decision like, what do I want to eat for lunch? Where am I going to go on Friday? The decision is either, are you going to reject the null hypothesis based on your p-value, or do you not have enough information to reject the null? Do you not have enough evidence? If you don't have enough evidence to reject the null, then you say, I failed to reject the null. So remember, you have to look at if p is low. If p is low, less than the alpha level of 0.05, you reject HO. And if P is not low, you fail to reject the null. So if we look back at my question here, I got a p-value of 0.0306. And 0.0306 is low. It's less than 0.05, right? 0.0306 is less than 0.05. So what do? I reject the null, and I conclude that it is statistically significant evidence to rule in favor of the alternative. So what does that mean in the context of the question? It means that indeed the HA is true, which means in context, the true proportion of students at her school is indeed less than 25% who have a part-time job. So the last step, step S, is to write a statement or a conclusion, statement / sentence in context about what does that mean based on your decision. So I'm going to put this together. It's kind of a two-parter. I'm going to say, because my p-value of whatever, in this case it was 0.036, is less than alpha equals 0.05. Usually we use 0.05. I say I reject the null hypothesis. That's my first thing that I say. And then I say thus, and what does it mean? Thus, in context, the true proportion of students at the school who have a full-time, part-time job is less than 25%. Thus, the true proportion of students at her school, this is the parameter of interest, by the way, who have a part-time job is indeed less than 25%. Okay, so you're making a conclusion based on your decision that you made. It's a two-part conclusion sentence. So I know it's long, but actually all of these components we've done over the course of the last couple of months. It really is just putting them together with the concept of the hypothesis and what does it mean to reject the null or not to reject the null, aka fail to reject the null. So because I had enough evidence to reject the null, I say that it is statistically significant and at the alpha equals 0.05 level, that indeed the true portion of students at her school that have a part-time job is less than the true the national average.